All right. Hey, Dejanel, Tarion. We're about to start class. We've had quite an eventful few minutes before. I just threw up, no big deal. All right, so we're looking over the 12-2 worksheet that you guys did. First, you said number what? Sorry? 7. Okay, so number 7 said, the permutation of 7, choose 5, and divided by the permutation of 4, choose 3. Okay, I misspoke a little bit when I said that here's someone else's keys. Did I grab his keys? No, here are mine. What in the world? Okay, y'all. All right, I said that when you do these, you can never get a fraction as your answer. But what I meant was when you do a permutation or a combination, you can never get a fraction. When you're dividing a permutation by a permutation, you can get a fraction if they don't all cancel. But like that alone can't be a fraction. And that alone can't be a fraction. But if that ended up being 3 and this was 2, you would have 3 over 2. Okay? So I said you couldn't get a fraction, but I think at least one of these, the answers was a fraction. Okay. So we need to work these separately. So first, what is the permutation of 7, choose 5? So think about what this means in a scenario. It's a permutation, so the order that things are chosen matters, right? And we have 7 choices and we're going to pick 5 of them. So what is the formula? 7 factorial over 7 minus 5 factorial. Okay? So that is 7 factorial over 2 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. So that ends up being 7 times 6 times 5 times 4 times 3 times nothing. All right, is 2,520. So that's what this is. Over permutation of 4, choose 3. Okay, so that is 4 factorial over 4 minus 3 factorial, which is 1 factorial, which is 1. So that is 4 times 3 times 2 times 1 over 1, which is 24. So this is 24. Then you just reduce this fraction, okay? 2 goes into both of them. 1, 2, 6, 0 over 12. 2 goes into both of those. 6, 3, 0 over 6. 2 goes into both of those. 3, 15 over 3. And 3 goes into both of those. 105 over 1, which is 105. All right? So then, hey, Princess, will you take these to Mr. Plump? I don't know why they're in here. All right. Was there another one you guys wanted to see of those? You just do them separately, and then you'd multiply them together and divide. So it's just algebra after that. I mean, just arithmetic after that. Okay. Let's look at the 4-word problems, because I want you to, well, there were only 2 that you did, but then I want to talk about the other ones. Okay. So the first one said, a photographer is taking a picture of a bride and groom with their 6 attendants. So like 3 bridesmaids, 3 groomsmen. Okay? So, and they're standing in a line. Now you could do this a permutation. Why would it be a permutation over a combination? Well, even more than that. What's the difference between permutation and combination? The order matters. We're counting how many different orders there are, okay? Or the other way I said is if you took an outcome and you mix it up, is that a new outcome? Yes, it's a different order, okay? So if it's a new outcome, that's a perm, not comb. Okay? So mixing it up, new outcome, that's a permutation. But what you would have to do if this were a permutation, if you work it like a permutation, is you would have two cases. You would have one where it's the bride on the right and the groom, and you got 3 and 3, right? But you could also have the groom on the left, the bride on the right, and 3 and 3, right? So really, it's like you take them out of the picture. You're just wanting to know how many different orders can these people stand in, right? So that's the permutation of how many choices do you have? 6. And how many are you going to put in order? All 6, right? So what is that formula? Which is 6 times 5 times 4 times 3 times 2 times 1 over 0 factorial is 1. So that becomes 6 times 5 times 4 times 3 times 2, 720. That works too. Okay, so this is 720. So there are 720 ways to do it with bride then groom. How many are there going to be to do groom then bride? Well, it's the exact same thing, right? Permutation, 6 to choose from, you're going to choose 6, that's 720. So if there's 720 here and 720 here, that is 1440 possible ways, right? Now the other way, which Ariana said, is you could do this as a counting principle problem. And actually on this one, it's probably easier to do counting principle, okay? You have 8 places that people can stand. But the middle 2 have to be the bride and the groom, okay? So how many choices do you have of people that can go here? 6. There are 8 people, but only 6 of them could be here. What about there? 5, because there's 8 to choose from, 2 can't stand there, and 1 has already been put here. So that's 5. Then 4. Then 2. There are 2 people that can stand here. But once somebody stands there, how many people can stand here? 1. The other one. Okay? Then how many can stand here? 3, 2, 1. And if you multiply all of those, you get 720. Okay? Now, number 12 is the one that gets us thinking differently because it's kind of like a permutation and it's kind of like a combination. Okay? So, 12. It says, how many different ways can 3 identical pen sets and 5 identical watches be given to 8 graduates? Okay. So you can kind of think of this as a permutation. You can kind of think of it as a combination. You cannot do this one as a counting principle. Doesn't work. Okay? So if we're thinking about it as a permutation, okay? So think about it. It's kind of like in the beginning when I was asking you how many different ways can you arrange the letters of a word, okay? Because if you think of this as pen, 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 and 5 watches, I'm really just wanting to know how many different orders you could put those in. Because this one is the first 3 people get a pen and everyone else gets a watch, right? But it could also be pen, pen, watch, pen, watch, 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 right? Now you don't have to write them all out. That's not how this would work. But if I switch these two watches, is that a different outcome? No, because they're identical, right? So it's like the words when you had a repeated letter, right? So how would that be? There are 8. It's 8 factorial over, there are 3 identical pens and 5 identical watches. So it's just like a word where 3 of the letters were all the same and the other 5 was the other letter. Okay? So that would be, the largest factorial on the bottom is 5. So you're going to say 8 times 7 times 6 times 5 factorial over 3 times 2 times 5 factorial. Right? Okay, and 3 times 2 is 6. So the answer is 56. Okay? All right, now there's a way to think of this as a combination. Okay, so I'm going to pause this for 1 second. And let's go to a smaller set and see if I can make this make sense to you. Okay? All right, so I'm going to, so I want everybody to stand up and come to the front of the room. Because I think if you physically do this, we'll be okay. All right? Desmond, Tariana, I'm going to pause y'all because you can't see this. So.
Everyone recording. Oh, y'all. Oh.
You can. You don't have to, but you can. Okay, so Algebra 2, no trig, March 8th.
I think she got one of the highest grades.